Have you ever wondered how atomic power, once seen as the panacea for all of mankind's energy needs, has evolved and transformed over the years? It's a story that begins in the early 20th century, when scientists first stumbled upon the atom's hidden potential. Picture a world where the concept of harnessing atomic power was as foreign as flying cars. Fast forward to the discovery of nuclear fission, the process of splitting an atom's nucleus to release a massive amount of energy. This was the key that unlocked the door to atomic power. This newfound source of energy was initially seen as a beacon of hope, a potential solution to mankind's ever-growing energy demands. Imagine the excitement, the possibilities. Power plants, spaceships, even cities could be powered by this seemingly limitless energy source. The journey of atomic power, from its discovery to its widespread use, has been nothing short of a roller coaster ride. As we moved into the 20th century, atomic power began to reveal its true potential. This era was a time of discovery and innovation, with atomic power at the forefront. The early part of the century saw the development of nuclear power plants, harnessing the energy of the atom to generate electricity on an unprecedented scale. Yet, beneath the promise of boundless energy, a darker application emerged. Atomic power was harnessed to create the most destructive weapon known to humanity, the atomic bomb. Key figures such as Robert Oppenheimer and Albert Einstein played pivotal roles in its development, their brilliance shadowed by the devastation their work would unleash. Countries worldwide raced to unlock the secrets of atomic power, with the United States, the Soviet Union, and others becoming major players in what would be known as the nuclear age. By the mid-20th century, the world had seen the awe-inspiring and terrifying capabilities of atomic power. But with great power comes great responsibility, and sadly, atomic power has also been the cause of some of the world's greatest disasters. Despite the vast potential of atomic energy, it has a dark side that we cannot ignore. Take, for instance, the catastrophic nuclear accidents at Chernobyl and Fukushima. These incidents resulted not only in immediate loss of life, but also long-term health problems and environmental damage that persists to this day. Chernobyl, the worst nuclear disaster in history, released an enormous amount of radioactive particles into the atmosphere, contaminating vast areas of land and affecting millions of people. Years later, the Fukushima disaster echoed these horrors, reminding us of the potential risks involved with atomic power. Moreover, the ethical and environmental concerns related to atomic power are profound. The question of how to safely dispose of nuclear waste, for instance, remains largely unanswered. These incidents served as a stark reminder of the potential harm atomic power can cause when things go wrong. Today, atomic power stands at a crossroads, balancing on a tightrope between its potential benefits and its potential dangers. At present, we are in an age where atomic power continues to be a formidable component of our energy mix, with nuclear power plants scattered across the globe, quietly humming away, providing a substantial portion of our electricity needs. While the atom's destructive potential is not to be taken lightly, it's important to remember the immense power it holds for good. This power is harnessed in nuclear reactors, where controlled nuclear fission reactions generate heat, which in turn produces steam to drive turbines and generate electricity. Today, advancements in technology and safety measures have made nuclear power plants safer and more efficient than ever before. Beyond the present, the future of atomic power looks promising, with several exciting developments on the horizon. One of these is nuclear fusion, the process that powers the sun and the stars. Unlike nuclear fission, which splits atoms apart, fusion combines them, releasing enormous amounts of energy in the process. If we can master this technology, we could potentially unlock a near-limitless source of clean, safe energy. Another promising avenue is the development of thorium reactors. Thorium is more abundant and less dangerous than uranium, the fuel currently used in most nuclear reactors. A thorium reactor could produce less waste, be less prone to meltdowns, and be much harder to use for weapon production. As we look to the future, it's clear that atomic power still has a significant role to play in our world, but it's up to us to ensure that it's a role that benefits humanity rather than harms it. The promise of atomic power is too great to ignore, but so too are its risks. Balancing these two will be one of the great challenges of the 21st century.